This actually will be, I will explain or present my thesis work about BIM model quality check in this hopefully 10 minutes or 12. So the table of content, we will just have introduction, have BIM explain BIM quality challenging, objectives, and also we will our methodology of collecting information. Then we will select one issue and try to develop it in develop phase. And after that, we will explain the conclusion. So what we are doing, actually, we are trying to step into intersection between BIM and the quality management. We are trying to stay in this area, intersection, and how we doing this, we actually look backward to what have been done before in BIM quality. And also we want to wear the glasses of companies to see the practical side by questionnaire and interviews. And from this, we collecting information, issues, factors have significant effect in BIM model quality, and then select one issue to try to develop it in develop phase to create it in automated way. So our objective here is diagnosis what is in the practical side in terms of BIM qualities and try to solve it in terms of automation. So from many dimension or dimensional controlling BIM quality, we choose four of them: accuracy, consistency, completeness, and timeliness. Actually, we will not go deeply, or we already didn't go deeply inside of them inside our thesis, but we will choose only one dimension, and we in next slide we explain which one. For the piece of information or information gathering and collecting information, we take it in both way. We publish questionnaire already, and we have a lot of entities, more than 80, and we also have more than 9 interviews with different BIM position, BIM manager, BIM engineers, BIM modeler, and BIM coordinator in different countries. So we already have a huge number of factors, issues inside BIM model. For example, we have here, we collected five more significant 5 issues. These issues addresses more times during our interviews. So we're thinking to choose one of these issues. You can find more details in this issue inside thesis manuscript, but there is no time here to explain each issue. But we're gonna select one of these 5 to go for developing phase. For the developing phase, which selected one which under umbrella of or under the dimension of accuracy, and not only accuracy, we only focus in inconsistency between information field, and we have not. It's this error or this issue. All of us can follow it inside your model in different way, and in this slide we explain in which area you can find this error. For example, in keynotes, as you can see here in this single flash door, this door material is wood. But in classification, the person who assigns the classification, because it has to be done manually in your template or in your model, it's already here in metal door. So as you can see, the material of this door, it's not coherent, and this means this information is strong inside your model. It's the same way here in classification. Whatever the tool you are using to assign the classification in BIM interoperability tool or automated way or manually in your template, also here, as you can see, this wall consists of concrete masonry units, but in the classification here, it's not defined as concrete masonry unit wall. It's a light steel wall frame system. So the same way here, you have incoherent information, you have wrong information inside your model, and it's need you to check it manually to check what's coherent with object parameter or not. One more problem, and this actually happened not during your template, during your model phase. When you are duplicated the column, for example, as you can see here, this column you already duplicated and renamed this column, but you forget to change the parameter inside your column to a new name. So as you can see here, there is no coherence between the name of object and the parameter inside this object. So from these three errors, we choose the third one. There is a question now in your mind why we chose this one. Actually, because the third one, it's having a probability to fall in this error. It's too high than other tools because this one's done during your modeling phase. But you know, for classifications can be minimize this error because you are creating your template in correct way. So why we choose this one? Actually, because this has significant effect in your construction drawing. If you naming this column with the name tag, so this means the column dimension is not coherent we choose only one object. No, it's considered for wall, for doors, for other objects. Naming is not coherent with the actual parameter or material or something like this. So how it can be solved? Normally, it can require from coordinator or reviewer to go manually check by vision or visual to check the name from object and then check it with actual parameter. But actually, this costs time and it's not totally accurate, because imagine we have here 4 columns or 3, but imagine you have 1,000 objects, doors, column, walls, floor. How you can go over all of this object by yourself to try to save it, to correct it or check it's correct or not. So the challenge is to make it automated way by developing add-ons. So the add-ons, this add-on or this tool has to be reading instead of human as intelligence way. You have to transfer human intelligence inside this code or inside this tool to read this text line and extract information from it. As you can see here, for example, as all of us as engineers, so from this naming convention, you can recognize RC is referred to reinforced concrete. If you change it to steel or S7725, this means it's steel. So this here intelligence, we already recognize it because we are a human. So the tool has to be transferred this or use this intelligence to extract this information. So the straightforward solution come for anyone of mind of you, it's okay, we can use regular expression or rule-based code to make a dictionary, for example. That's exactly what we try to do. We already create rule-based programming by Python. There is a library called regular expression. From this regular expression, you can extract letters and extract numbers and try make a list between them and then compare it with actual parameter you have. So we already do this. We create a dictionary. If you find RC inside your text naming convention, this means concrete. If you are some different other names, key, that will return to you the material or the dimension from your model, from your object. We can say we are already solved it, but unfortunately, if you have here, for example, baton as a concrete in Portuguese, I'm not sure I'm pronouncing it right or not, but this actually means concrete in Portuguese. So you need to go inside your code model to add another definition inside your model according to each or new update in your naming conventions. That's actually make you, it's harder to go inside and background in your code to update your tool. Also for naming convention, if you have, for example, different numbers inside your text line, that means you cannot extract right information. You go blindly to check your model, your accurate information or accurate dimension. So that cannot be generalized and it's need expertise. So we need to think deeper and wider to find another solution. We proposed machine learning approach to do it instead of creating transfer intelligence to codes. We make it more generalized by machine learning. For people who do not know what is machine learning when you are kids, for example, touching fire, so that's when you are feeling hurt. And with some time experience, some examples or some trials, your mind already recognizes touching fire hurt. Exactly the same here in machine learning. We're creating data set with the big number of examples, of naming convention with different material, different dimension, and train this machine learning to models to create a connection between these examples and then have a prediction or result. That's exactly what we did. We create more than 2,700 examples of the data set, and then we trained the machine to can predict this from names. And because we're using Python, we couldn't make this implementation inside BIM Authority tool Revit. We have to create external tool. So we create external tool. We export this information from Revit as a CSV file, and then create this check outside Revit. As you can see here in this short video, this is a column we have here. The object is not the same. The information here is not correct. So we just here creating check with rule bit inside Revit, but this will not work. We have here our checking toolbox we created as outside from Revit. When you just open it, you will come with a new tool inside your computer. And with this tool, you have to just go and import your CSV file, which we will export it from Revit right now. As you can see here now, we just open Revit, check this tab we created from scratch also to export required information. We're gonna check object parameter, object name, and actual parameter from this from your model. And then you have to go to the path of this file, as you can see, and import it to your tool. So right now we're gonna actually this tool we implement machine learning and rule-based. It's just two ways to make double check. As you can see here now, we're importing our data inside our tool, and then we just go for extract. Extract for rule-based, we just extract information, and for machine learning we predict. As you can see here, user input and his object parameter. The results now show which object is failed, which object is passed, which object is correct in data, and which was not. So in machine learning, it's take more time because we downloaded this model from online. We already upload this model in open source cloud, and it's already trained and ready to predict. So we created in generalized way. You can update your data set for other naming convention. So the question is how we already solved it. Unfortunately, no, because actually we reached to accuracy 90%. This is acceptable accuracy. That's not acceptable for our tool because we need to reach 100 at least. So, but there is the reason because we already limited with our data set. We have only 2,000 data set examples. It's not too much. And we with update, we can generalize it. We can make it more accuracy than 90%. So one more question, and I think it will be the end. What if the change example test from your dataset? You will have new naming conventions totally. So unfortunately, it will not work 100%. It will still have like 50% accuracy because there is some overfitting in our models. So we come up with a new final approach is active learning. We just export our tool. Make it check if the number of errors is too high, that will ask user to write naming conventions, auto-generate from his naming conventions, new data set, add it to the previous one, retrain our model, and then upload this to our open source cloud and download it for that check model for next time. So with 10 trials, it will covering all kind of naming conventions. It will be covering all kind of examples. It will be reached to accuracy 100%. So the conclusion, as you can see, the BIM model quality is essential to reduce time and cost. Controlling can be done by modeling manual. You can control your BIM model quality. It can be checked by checklist, other external tool. We try to solve data consistency by rule-based and machine learning. Both of them has pros and cons. Rule-based cannot be generalized. It need expertise to go inside your model, inside your code to update it. And machine learning is still not 100% accuracy, but can be generalized and can be updated and developed according to last active learning we proposed. Okay, thank you for time, and it's time for questions.